Hi everyone, this is our data mining final group project. Our group member is 朱宇杰、黄子敏、黄义珍、李彤、林庭轩、连德君、陈博宇. Today, we want to introduce a data from government open data website. The data we choose is about diabetes patient examination rates, the index about disease type, which is from Ministry of Health and Welfare Central Health Insurance Agency. This is our website URL. Next, I want to introduce our data. The original data, we have 389,186 data. It's too many to analyze for us. So we just take the 2023 years data. The total numbers of the data is 9,252, but it has some duplicate data, so we delete them. The final numbers of data is 7,385. The variables we use are special category, number of people performing urine microalbumin test A, number of patients with diabetes and taking diabetes medication B, number of declared doctors, average age of patients, major injury rate among patients, number of major injuries and denominators, number of physicians participating in diabetes care progress, county and city, participating institution or not. These are 10 variables we choose to use. These are 9 independent variable and 1 target variable. The second, I want to introduce our data cleaning and pre-processing. These are variables we drops. We drops the year, the medical institution code, the medical institution name, the township, the urine microalbumin test implementation test AB. We drop year, medical institution code, medical institution name, the township, and urine microalbumin test implementation rate AB because we based on the pattern. These are no pattern, so we drop it. The main, we drop the microalbumin test implementation rate AB because it is number of people performing urine microalbumin test AB. Divide the number of patients with diabetes and taking diabetes medication B. It is the duplicate number. We pre-processing 2 variables. One is special category and the other is county and city. We use Excel to transform special category to ASCII code. Use label encoder because we see it an ordinal data clumens. The reason why we see it as ordinal data clumens because we think each hospital have each level responsible for different care tactics. The purpose of hierarchical medical care is to allow hospitals to focus on acute and critical care. The other we pre-processing is county and city. We use Excel to divide to 5 classes. We use one-hot encoder because we see it as not an ordinal data clumen. The reason why we divide it to 5 classes because the original data, there are 12 classes in the data. These are too many for us to build a model, so it is not easy to analyze.
Next is the decision tree part. I didn't perform additional discretization because decision tree can handle continuous variables, including such as preprocessing. Because this is unbalanced data, so I perform resampling. The following section will be performed using undersampling, oversampling, and small respectively. Under the 3 resampling methods, chi-square choose 5 features. Select from model only choose 1 feature. It means that 糖尿病照护方案参与医生数 is directly related to the result. So subsequent modeling will not use partial variable select from model. Under sampling, the best parameter for both variable and partial variables are C equal to 0.1, M equal to 2. Both test accuracy is 95.75%. Under oversampling, the best parameter of both variable are C equal to 0.1, M equal to 2. The best parameters of partial variable select by chi-square are C equal to 0.1, M equal to 8. Both test accuracy is 95.11%. Under smooth, the best parameters found for both variables and partial variables are C equal to 0.1, M equal to 2. The full variables model test accuracy is 96.26%. The partial variables model test accuracy is 96.62%. Use the CART algorithm to compare Gini and entropy criteria, respectively. Both the test accuracy under sampling is 95.75%. Both the test accuracy under oversampling is 95.11%. Under smooth, when the criterion is Gini, it has a higher test accuracy rate of 96.62%.
Next is the part about RC 4.5. First, all the character variables in the diabetes data were converted into factors. Then, as mentioned earlier, the category proportion of the target variables are seriously uneven and belong to imbalanced data. Therefore, we also perform undersampling and oversampling in R. In parallel, double loop is used to find the best accuracy rate among different combinations of C value and M values. The result is that when C is equal to 0.25 and M is equal to 10, the test accuracy rate and training accuracy rate are both 0.95. Among the 5 variables data selected by the chi-square test, we found that when C is equal to 0.25 and M is equal to 2, the maximum test accuracy rate is 0.955 and the training accuracy rate is 0.965. This is a comparison of the accuracy of the 2 resampling methods calculated by C4.5 with 4 variables and partial variables. The highest accuracy rate is the test using oversampling and partial variable. variable, which is 95.5%.
In summary, we chose to model partial variable select from chi-square under the smooth resampling method. Use CAD algorithm by Gini as the final decision tree. There are 21 leaves and the tree size is 41, and the test accuracy is 96.62%. From the result, we can see when 糖尿病照护方案参与医师数 less than or equal to 0 and 执行尿液微量白蛋白检查人数 -A less than or equal to 2.029 and 申报医师数 more than 1.738, then it belongs to the category no. That is, it will not participate in the program institute. When 糖尿病照护方案参与医师数 less than or equal to 0 and 执行尿液微量白蛋白检查人数 -A range from 2.029 to 2.825, then it belongs to the category yes. That is, it will be participating institution.
Association rules. Association rules only accept nominal variables, so we need to discretize the data. There are two methods, equal width and equal frequency. We will use equal width for variables such as 病患平均年龄、申报医师数、病患重大伤病比率、分母重大伤病人数、糖尿病照护方案参与医师人数。For variables such as 执行尿液微量白蛋白检查人数 -A, 糖尿病病患且使用糖尿病用药之病人数 -B. We will use equal frequency due to the large and disparate data range. And we are talking about association rules in Python. We set the support to 0.5 and the confidence to 0.7, which yields 527 rows. However, we couldn't find rows where the target variables is yes. Therefore, we need to perform resampling, use both oversampling and undersampling, with support set to 0.5 and confidence set to 0.7. In the case of oversampling, rows as index 90 and 93 are identical. Rows as index 90 and 162 have the same confidence and leaf, indicating that 申报医师数 as index 162 is an irrelevant variable. Hence, we select the simpler row, index 90, where 病患重大伤病比率 between 0 and 0.333, and 申报医师数 between 0 and 240 are likely to co-occur with 基层医疗单位 and 病患平均年龄 43.55, 69.77. Second, as index 170, where 病患重大伤病比率 between 0 and 0.333 and 申报医师数 between 0 and 240 are likely to co-occur with 糖尿病照护方案参与医生数 between 0 and 55. 基层医疗单位 and 病患平均年龄 between 43.55 and 69.77. Both rows have a confidence of 0.8328 and a leaf of 1.0135. In the case of undersampling, we select rows as index 90 and 93. The row as index 90 indicates that 病患重大伤病比率 between 0 and 0.333 and 申报医师数 between 0 and 240 are likely to co-occur with 基层医疗单位 and 病患平均年龄 between 43.55 and 69.77, with a confidence of 0.8290 and a leaf of 1.0136. The row as index 93 indicates that 基层医疗单位 and 病患平均年龄 between 43.55 and 69.77 are likely to co-occur with 病患重大伤病比率 between 0 and 0.333 and 申报医师数 between 0 and 240, with a confidence of 0.9309 and a leaf of 1.0136. Next, we are talking about association rows in R. We set the support to 0.07 and the confidence to 0.7, which yields 2 rows. From this, we can see that the row as index 1 can determine that the target variable is null without any conditions. So we need to perform resampling. For both oversampling and undersampling, we set the support to 0.07 and the confidence to 0.7. Sorting the rows by list, we get the same rows. We choose the rows as index 2 and index 7. As index 2, when 执行尿液微量白蛋白检查人数 -A is low, the target value is null, with a confidence of 0.991 and a leaf of 1.8442. As index 7, when 执行尿液微量白蛋白检查人数 -A is high, the target variable is yes, with a confidence of 0.8139 and a leaf of 1.6278.
And now it's a part of SVC. SVM can directly handle continuous variable, so there is no need for discretization. And the data encoding status is consistent with the above, so it's no need to recoding. And the continuous variables need to be standardized in SVM, and we choose 4 parameters and 2 ways for testing. This is pictures in linear SVC, and this is a model with SVC, and we get an accuracy of training and testing model, choosing the best testing model with SVC4 because its training accuracy is 97.2% and its testing accuracy is 97.02%, and this is a part of random forest. Random forest can directly handle continuous variable, so it is not need to discretization too. Random forest is a tree model instead of a distant models, so random forest should not be standardized. And this is the features we build in random forest. We choose 4 parameters for testing and get the accuracy of training and testing model, choosing the best testing model with parameter 1 because the random forest 1 in training accuracy is 98.91% and the testing model is 97.42%.
Because KNN is a classification analysis method based on calculating the distance between data and measuring their similarity, we retain the continuous variable characteristics and do not discretize them. As for the coding part, we use one hard encoder for the multi-category variable 线识别, and for the ordinal scale 特约类别 variables, we use label encoder. Then split the dataset into 80/20 training dataset and test dataset, and standardize all other numerical variables with the standard deviation and mean of the training dataset. Since there are too many records in the dataset, I use loops to run only k values from 1 to 100 to calculate the accuracy of the training dataset and test dataset, saving calculation time and cost. Finally, the best case is 3. The training accuracy is 99.966% and the testing accuracy is 95.599%. This is about example learning. We use the forward 3 best parameter models with soft hard voting to establish an example analysis and obtain accuracy rates of 97.16% and 97.22% respectively. Compared to the test accuracy rate of the 5 models, the final result can be found that random forest has the best test accuracy, which is 97.427%.
I will introduce the part of k-means. First, we determine the number of clusters by 3 plots. We saw SSE have an obvious decrease. Number of clusters is between 4 to 6. So our next step is clustering 4 and 6 clusters to decide the number of clusters which have the smallest SSE. As we can see, because dividing 3 clusters has the smallest SSE, we chose it as the number of clusters. Second, the process of determining the number of clusters with target variable is the same as the former steps. Thus, the 6th cluster also have the smallest SSE, and then we chose it. Finally, according to the 2 results from the previous steps, we would like to choose 6 clusters as k, the final number of clusters due to the smallest SSE.
We divide into 6 groups in total, and the results of the 6 groups are as follows. Based on the results and characteristics of these 6 groups, we can name them. Cluster 1 is health management elite. This cluster may include people who attach great importance to health management and medical issues. They may be more inclined to proactively manage their health and seek high-quality medical service and advice. Class 2 is comprehensive health care. This cluster may represent people who are interested in holistic health and wellness and may seek out a variety of different healthcare and treatment options to maintain physical and medical well-being. Cluster 3 is basic care groups. This cluster may be people seeking basic medical and health care service and may be more concerned about basic medical needs and accessibility of service. Cluster 4 is diabetes focus. This cluster may including people with diabetes or people concerned about diabetes issues. They may seek specific information and support about diabetes management and treatment. Cluster 5 is health priority. This cluster may represent people who prioritize health and may focus more on health, lifestyles, and preventive care. Cluster C is special needs group. This cluster may include people with special health needs or needs for special medical service. They may require more personalized and specialized medical and health care service. Finally, the accuracy rate based on majority voting in each cluster is 78.2%. Now, conclusion. According to the test accuracy, the best classification prediction model is random forest. The accuracy rate is 97.43%. Since random forests use different random samples and features subset for each tree, this helps reduce overfitting, especially when dealing with complex data. Therefore, random forests usually have higher accuracy than single decision trees.
结束了吗？应该吧。
好，结束。